Hello fellow problem solvers, so today we're going to be doing a problem from the Poland theme selection test from the year 2000, problem number 2. I suggest you try this nice geometry problem out for a minimum of 20 minutes, ideally an hour to maybe 2 hours, not more than 4 hours. If you'd like to go along with us, give this a go, especially if you're doing medium level geometry. For the next 10 minutes, just draw the diagram, put your first ideas out on paper, and now let us begin. So what do we have here? We have a triangle with AC equal to BC. Okay, so we have some triangle here, C, A, B. And what do we have? We have a P inside such that PAB, okay, PAB, boom, is PBC. So, oh, actually, no, it's PAB is boom, PAB is PBC is boom. So P is in here. Okay. And we need to have M is the midpoint of AB. We need to show that APM, okay, that this angle plus this one is equal to 180. So how are we ever going to do this? Well, the first things first, we can look at a problem forwards or backwards. Here, looking at the problems forwards, what do we notice? Let's take this one point at a time. CA is CB. And look at this condition for point P, because P here is the new point, so to speak. What do we have for P? Well, we have, PAB is PBC. What does that mean? And the answer is, well, it means that CB and CA are tangents to this circumcircle around this triangle PAB. And now with this in mind, I invite you also to pause for the next, 10 minutes and try to push the problem further. And now without further ado, so what is the next thing that we notice here? Well, see sort of a tangent to, we can sort of rephrase the problem as C is a tangent, CA and CB are, C is where the tangents meet in this obtuse triangle PAB, M is the midpoint of this side AB, and we must prove this condition, right? C can sort of be thought of as an afterthought. Now looking at it backwards, what is this condition? This is x, 180 minus x, which means this is y, 180 minus y. But what else does that give us? All right, what else do we have from this? And the answer is there's a different way for us to look at the whole situation. And the thing is if I intersect PB, again with the circumcircle, I need to prove that if this intersection is called, say, Q, I need to prove that QBP is MPA, right? That is sort of the equivalent thing I need to prove. And why do I want to intersect it? Well, when I intersect it, I have a lot more angles, right? I have this angle. I know if this is X, I know that this angle right here is also X. I'm intersecting. And then I'm not just proving some angle condition, but I'm proving similarity. And given that I cannot get to the angle directly, and I have this midpoint, and midpoints are sometimes hard to deal with, it's good for me to intersect, and then I'm changing what I'm trying to prove. I'm trying to prove not that these are the same angle, but rather I'm trying to prove that these triangles are similar. Now think about this. What would I have? If I had this angle, I would also have this angle, sort of by extension, I would have this angle is equal to this angle. And I would also then have another similarity, called this angle here that we have alpha minus x. Then I'd have alpha minus x here. I would have the same thing on the other side, right? If this is equal to this, then because we share this angle, then this angle is equal to this one, and then I have two similar triangles. So I have two similar triangles here, if the problem condition statement holds true. So now let's look at this in another way, which is to say we have a point. Okay, this was, let's look at the triangle like this. We have P, where the tangents meet up. They meet up here at C. And then we have CP intersects the circumcircle at some point. We call this x, x, alpha minus x, alpha minus x. And this is something that we know. We know that this angle is x. We know this is alpha minus x. Like if we look at it in terms of this tangency condition. Now I would have two things. Like I would have something for these two triangles and these two triangles. So instead of saying, hey, I'm going to have two things. If I have this one thing, I'll have two things. Here the idea is like, let's get us the two things and prove that we have this one unique thing. That's sometimes a thought in geometry. If you get two things at once, if one thing holds true and it gives you two things, redefine that thing such that you have the two things and prove it's the same thing, or use a phantom point. So here, let's take a point on line AB called M prime, such that M prime PA is equal to what I call this Q, QP, QPB. Right? And then what do I have for M prime? Well, I have that the triangles, what's it called? M prime PA is similar to the triangle Q, and so M prime is where B is, B, PQ. And I also have M prime PB is similar to the triangle A, P, and Q. And now what do I have? I have MA over M, I'll have M prime A. I'll need to show that M prime A is M prime B. I'll have M prime A over, say what? I'll have M prime A over BQ is equal to, well, I have on both sides. Well, on both sides, I won't have PA. PA and PB are different. But I'll have M prime P. I'll have this as M prime P over, what is this? BP, right? BP. And then similarly, here I'll have, I usually like to write it down like this instead of, so M prime P. I'll want to like get M prime A over M prime B is 1. So actually let me write it, M prime B is then equal to M prime B over M prime B, AQ. And then we have M prime P again, M prime P over BP, AP. Now, I need to show that M prime A is equal to M prime B. And I invite you here to pause for the next 5 to 10 minutes and see if you can push the problem further. And the thing is, I need this to equal this. Under what conditions is M prime A equal to M prime B? Well, it's equal if M prime P and cancel out here. And it's equal if and only if BQ over BP, if this is equal to AQ over AP, like when I multiply these things through. So now I need to prove this. And now this, so I need to prove that BQ over BP is AQ over AP. Now let's go at the problem forwards. Do I have this? And the answer is, where do I get BQ over BP? Right? I get BQ over BP in this similarity that gives me the tangency condition. Right? I get the similarity that gives me, the similarity really is that the triangle, what? CBP, CBP is similar to the triangle CQB. And this gives me what? It gives me BP over QB, or I get that BQ over BP, and this over this is equal to what? Well, it's equal to CB, yes. And I want this because CA is equal to CB over CP. And then I'll get similarly on the other side. Mind you have symmetry with respect to A and B here. You want to use that symmetry. This is why we get two things instead of one. And I get this is equal to CA over CP, which is equal to, using the other similarity, is equal to AQ over AP. So now we have this, in fact, is true, which means M prime A is M prime B, which means M is the midpoint of AB. And so we know that M prime and M are the same point. In other words, we know that for M, this angle is equal to this angle, which means that MPA plus BPC is 180. And this finishes up the problem. This is also called this reflection, this line CP, is called the cymedian of the triangle APB and the P cymedian. This has a lot of properties associated, but one of them is that it meets this point of tangency. This finishes up our problem, and as always, thanks for problem solving.